my final project, I did magnetic levitation, and in this video we'll be exploring on how we can achieve such a feat. And so the first part to making any electromagnetic project is, of course, to have the electromagnet. This is the hardest part of the project, in my opinion, and that's because it takes a long time for you to make the electromagnet. For me to make the electromagnet, I used about a 3/8 inch bolt, which was about 4 inches in height, and I wrapped 0.45 millimeter magnet wire around it until it was a 1.75 inch diameter bolt, which is about 2 inches in height. In order to suspend the electromagnet in air, you need to create a small little frame that'll give space below the electromagnet in order to hold small metal objects. In order for this project to work, we need to make the circuit, and so I'll be explaining how the circuit works now. And so basically you need a circuit because you want the levitating object to give feedback about where it is in the device, because the magnet needs to be at the right power at the right time. If it's too low, the magnet needs to have a high voltage, but if it's too high, it needs to have a low voltage so that the object can levitate at the right part. And so in the red part of the circuit, we have 2 different photocells and an LED. So one photocell is a reference photocell, and that's for like dynamic calibration. So the LED can always see this photocell, and the voltage input will always be constant due to this photocell. The second photocell is the object photocell, and when the object is being levitated, it should go in and out of the in front of the photocell. And so when the object is too high, the LED will be blocked off to the object photocell, but if it's too low, the object photocell can see the LED. And so these 2 voltage inputs will go into an operational amplifier, and this op amp is set up as a differential amplifier so that the output voltage is the same. It's a variation of the involved resistors and the 2 input voltages from the 2 photocells. And so when there's an object in front of the LED and the object photocell, then the output from the op amp is going to be very low. Otherwise, if there is no object, then the output is going to be very high. The green part of the circuit is a high-pass filter, which we call the compensation network. And so the voltage that is output by the op amp is then transformed by this high-pass filter by filtering out all the low frequencies given out from the first op amp. And if the object is not doing well under the levitation device, like if it starts fluttering, this is the part of the circuit you would fix, by example decreasing the 150K resistor value or increasing the 1K resistor value. After that, in the blue section, we have a non-inverting amplifier, and so the point of this is to transform the input voltage into a more appropriate output voltage for the electromagnet. The purple section is the electromagnet part of the circuit, and we have the actual electromagnet in the circuit, and in order to power the electromagnet, we need a transistor. And there's also diodes that pretty much help prevent the transistor from damaging itself. There's also a debugging LED, which kind of tells us what the electromagnet is doing. So the electromagnet is on, the LED is on, otherwise the LED is off. If your circuit is built correctly, you will end up with an awesome levitating metal object. It can't hold too much weight because the electromagnet wasn't built to perfection, but we can see that the actual project can still work. Thank you for watching this video.